Alright, this is 1-1 notes, manipulating equations. Your objectives, you'll be able to use inverse operations to isolate a variable in any given formula. So we're going to be practicing a whole bunch of formulas and isolating variables that they're asking for. And you can take that same concept and apply it to any formula. So do not write down anything just yet. Let's talk about the material. So looking at this. 1-1 CW1 manipulating formulas. Let's actually make this a little bit bigger. The formula for finding area, A, in this formula, of a square with the length L and the width W is given. So A equals length times width. Something you talked about already in grammar school. Which formula shows that the length, so we're looking for the length, isolating that variable, of a square can be determined from the area and width formula. So from the area formula here, so our goal is to get the L by itself. To get that L by itself, this is L times W. The opposite of times is division. So our area formula is equal to length times width. To get the L by itself, we do the opposite of times W, so we divide by W to both sides. So A divided by W is equal to L. So the length by itself is A divided by W. So we look at our choices here. A is equal to L times W, no. A is equal to W times L, no. Length, which we're trying to get by itself, is equal to A times W, nope. L is equal to A divided by W, well, that's what we got here. So the answer here is D. And length is equal to area minus W, no. So that's the answer to number 1. Number 2. So same formula. Area is equal to length times W. However, now they're trying to get the width all by itself. So which formula shows how the width of a square can be determined from the area and length formula? Or from the area formula. So to get the width all by itself, so we know area is equal to length times width. To get that width all by itself, the times L, we divide by L to move it to the other side. So A divided by L is equal to W. So width is equal to area of the square divided by the length of the square. So W is equal to L divided by A? No, because we know it's A divided by L. Area is equal to width times length? Well, we know that's true, but we're trying to get W by itself. W is equal to area minus length? Nope. W is equal to area divided by length. Yep, that's D, so 2 is D. Three, the formula for finding the perimeter, P, of a rectangle with the length L and the width W is given. So it's a different formula now. So perimeter is equal to 2 lengths plus 2 widths. Which formula shows how the width of a rectangle can be determined from the perimeter and the length? So our goal here is to get the width by itself. So we have to get the W by itself. So P is equal to 2L plus 2W. The opposite of plus 2L is minus 2L, so we're going to subtract 2L from both sides. So we have P minus 2L is equal to 2W. Then the opposite of times 2 is divide by 2. So we're going to then divide by 2 to both sides. And we're going to get, right over here on the side, W is equal to P minus 2L divided by 2. If we simplify it, one way we could simplify it is P divided by 2, or half P, minus 1L. That's negative 2 divided by 2 gets you negative 1. So that's another way we could write it. So we know we have to get W by itself, so A is not an option. W is equal to P divided by 2. that looks like what we're doing, times L divided by 2. Nope, that's not it. Width is equal to area plus length divided by 2 times length. Nope, that's not it. Oh, look at that. It's going to be D again. P minus 2L divided by 2. What we got up here. Where we're at. Number 4. A formula for finding the volume V of a cone with a radius R and the height H is given. So this is the volume of a cone. Pi times radius squared times height times a third. Which formula shows how the height of a cone can be determined from the volume and the radius. So our goal is to get the height all by itself, the H. So that means we have to divide by a third to both sides, and we also divide by a pi and divide by radius squared. So if I rewrite it, volume is equal to pi times radius squared times a third times the height. So all this is being multiplied to the height. So we're going to actually divide by all of it, because it's all multiplication being multiplied to the height, so we could divide by all of it. So what we have is our volume divided by pi times radius squared times a third is equal to the height. So the height's now all by itself. Now, a third when it's in a denominator, that's the same thing as 3 over 1. Division divided by a division. So that would be the same thing as 3v divided by pi times radius squared. So our answer for number 4 is A. Looking at number 5, we have our same formula. However, now we have to get the radius all by itself. So we take that same concept and we do the division. So volume is being divided by the pi. Now instead of the height being by itself, it's going to be the radius squared by itself. The height's going to be on the bottom. And instead of dividing by 1/3, 1 over 3 is the same. Divided by 1/3 is the same thing as 3 in the numerator and a 1 on the bottom. So that's how I get that. Radius squared, that means we got to take the square root to both sides. So we're going to have the square root of 3v in the numerator divided by pi times height in the denominator of the fraction. And that's equal to r, the radius. So it won't be A. It's not C because they don't have a square root. H is being multiplied by that, so that's not working out. So it has to be B. Square root of 3v divided by pi h. Alright, looking at number 6. Make it a little bit bigger. Alright. Formula for finding volume V of a cylinder. So we have this volume of a cylinder formula right here. Our goal is to get the radius by itself. So that means we got to move the height and the pi to the other side. And it's being multiplied to the radius squared, so we have to divide. So we have volume divided by pi and the height. So pi and height, since they're both being multiplied to r squared, they go on the bottom. Or that fraction, and those two are being multiplied together. And that's equal to r squared. Now to get rid of the squared, we do square root. So we're going to have the square root of v divided by pi times h. So we have here B. Number 7 here. Our goal in this one is to try to get the height all by itself. So pi times radius squared times height. Well, both the pi r squared is being multiplied by the h, so we gotta divide it all. I'll write it all out just to make it a little bit easier to see. So pi times radius squared times the height. Our goal is to get height by itself, the h. So we have to put the pi on the bottom because it's being divided that by both sides. And we got to put the h on the bottom. Whoops, sorry. We're solving for that, so we have to put the r squared on the bottom. And then the h is all by itself. So volume of the cone divided by pi r squared will get us the height of that cone. So h is equal to v divided by pi r squared. Number 8. The formula for finding surface area of a cylinder is what we see here below. A is the area of the cylinder, r is the radius, and the height h is given. Now, which of the formulas shows how the height of the surface area of the cylinder can be determined from the surface area and the radius? So our goal is to find the height. So to get that h all by itself. So the opposite of plus 2 pi r squared is subtract 2 pi r squared. So we're going to take that area and we're going to subtract 2 pi r squared. And that's equal to 2 pi r times height. Then we got to divide by 2 pi r to both sides. That's a minus sign, 2 pi r squared. Cool. And that'll get us our h all by itself. So h is equal to a minus 2 pi r squared divided by 2 pi r. A little bit wild. Number 9. The formula for finding the force F with a mass m and the acceleration a is given. So F equals m times a. This one's a little bit easier. Fine. Why don't you first try this one on your own? Which formula shows how the mass, so we gotta get that mass all by itself, the m. Alright, so let's do it together. So F equals m times a. Hopefully you knew to divide by a to both sides. So F divided by a is equal to m, which is D for number 9. Same formula. Why don't you try to get the acceleration by itself all on your own by hitting that pause button. Alright, now you unpaused. F equals m times a. We have to get that a all by itself, so you divide by m to both sides. So we have F divided by m is equal to a. M divided by F is not the same, so cancel that out. A is equal to F divided by m. So number 10. Number 11. Find the formula for acceleration, is what here below. Vi is the initial velocity. The final velocity is Vf. So Vf minus Vi divided by t, when t stands for time. So our goal here, which formula shows how the time in which the change occurs can be determined from acceleration, initial velocity, and final velocity. So we have to get that t by itself, which all the multiple choice have t by itself. Cool. So what we got to do, we got to multiply by t to both sides. So then we have t times a is equal to the final velocity minus the initial velocity. And then we got to get that a back down to the other side, so the opposite of times a is divide by a. Those a's cancel out. So we have t equals the final velocity minus the initial velocity over the acceleration. Which is option A. Number 11. Number 12, same setup, except now I want you to try finding initial velocity all by itself. So we multiply by t to both sides. So we have TA, t times a, is equal to the final velocity minus the initial velocity. Now remember, the goal is to get the initial velocity all by itself, that VI. So we have to subtract VF from both sides. So we have, I'll do it in a different color, T times A minus the final velocity is equal to the negative initial velocity. So if we multiply everything by -1, we change all the signs, so negative TA plus the final velocity is equal to the initial velocity. That's manipulating formulas there. And you can also try getting the final velocity all by itself. Now number 14 is a little bit trickier. Let's make that a little bit bigger. Some people get confused because there's two equal signs. So it is on a little more on the challenging side here. So the formula for finding the frequency f with the number of cycles n with a period t and the amount of time t is given. So f is equal to 1 over t, which is also equal to n divided by t, where these two t stand for different things. Capital T stands for the period, and lowercase t stands for time. So which formula shows how the number of cycles, well, number of cycles is n. So our goal is to get n by itself. Determined from the frequency and the amount of time. So what this formula does, in which they could show up on other assessments, is giving you two formulas all combined into one. We don't need f equals 1 over t is equal to n over t. In fact, since we only need the n, we don't have to worry about this 1 over t. That's just extra information. So f equals n over t. So f equals n over t. In life, we get lots of extra information that we don't need once in a while. I just have to determine what's the critical information that you need for at the moment. So we have to get the n by itself, so the opposite of divide by t is times t. So we got f t is equal to n. So f times t. So that'd be A. Number 15 here, same formula. However, now they're going to ask for the period. The period is the capital T. So in this case, we need that capital T, so we don't worry about this extra information of equals n divided by t. We know f equals 1 divided by capital T. So we multiply by capital T to both sides, and we get capital T times f is equal to 1. Then we divide by lowercase f. We get capital T all by itself, and that's equal to 1 divided by lowercase f. So the answer is D. Why don't you try this one on your own? Here's a hint. You want to find the amount of time. The amount of time is lowercase t, so you need that lowercase t. So you don't need this extra information. So f equals n divided by lowercase t. Multiply by lowercase t to both sides, and then divide by f to both sides, so we're going to get n divided by f is equal to lowercase t. So that one's B. All right, if you have any questions, email me. Have a good night.